Hello and welcome to the ISIS tutorial. I am Felix and this is episode number 3. In this episode we will talk about structures and lists. In the last episode we saw that while we can combine similar things together in arrays like this, a equals square brackets 2, 3, 4, we cannot combine strings and numbers in an array like b equals 2 and the string a. But sometimes we just want to do that. So how would we go on about that? How would we combine different variable types together into one unit? The answer is using lists. A list is defined by the variable name and then curly brackets and then let's say an integer, a string and a double type, and then close the curly brackets, semicolon. And if we have a look what L is now, ISIS tells us it's a list type with 3 elements. And when we print this list, we see nothing was typecast to any other type, so the number 4 stays an integer. And ISIS prints out little curly brackets before and after the list to make clear we are looking at a list. Why would you not use lists all the time then, when they seem to be more versatile than arrays? The answer is because you cannot do calculations with them. If we define a second list, L2 equals 4, 5, 6, which is a list now only of integers, and then try to add the list L to the list L2, ISIS tells us that we cannot add list types. And rightfully so, because now I'm trying to add a string to an integer. But even if we define another list, let's say L3 equals 7, 8, and 9, and try to add L2 plus L3, we get the same error. And that's because lists intrinsically can have any data type, and ISIS does not know which types you used in your list, and so does not allow you to do math with them. To index a list, we use square brackets, just like for arrays. So to get the first entry of our first list, we say L of square brackets 0. And to get the second entry, L of 1, and so forth, L of 2, L of 2 would be the last entry. And just to show you that we can combine anything in lists, we can also have arrays as entries in lists, like LA equals the list, and then we define an array 3, 4, 5, and then maybe a string, and then maybe another array which maybe has a different length. And then we can print out the list LA, and you see we get the information, what's in the list, and we get the overview information about the arrays. And we can get the array in the first entry of the list by doing LA of 0, and then we can get the first entry of that array by just using another pair of square brackets behind that. So LA of 0 to get the array, and then again square bracket 0 to get the first entry of that array. And that's the number 3, which was the first entry, correct. Well, that's all great, right? We can now combine any number of things in lists, but we have to remember at which position in the list we put which information. And sometimes this can get confusing. So structures can help you to keep things organized, because in a structure every entry has a name, or every entry is a so-called field. To define a structure, we say, let's say the structure team equals, and then we have to type struct curly brackets. So to define a structure, we cannot just use a certain kind of brackets, but we have to say struct before the curly brackets. And then let's call the first field name and put in an array of strings. Let's say Götze, Klose, and Müller. And then the next field we will call matches, which is an integer array 6, 5, 7. And then one more field which we will call goals is 2, 2, and 5. And as a last field, just to show you that you don't have to use the same size of arrays for all the fields, we just define the field year, which is just the number 2014. And then close our structure, semicolon, and we're done. When we look at team, we see it's a struct type with 4 fields. So the 4 fields we defined, that is name, matches, goals, and year. And then we print that, print team, and we get the name of the fields printed out together with their value. Again, the overview information if it's an array, and the value itself if it's a single number. To address the fields of a structure, we have to specify the name of the structure and the name of the field, of course. So to get information about the name field, we would say team.name. So we combine the field name to the structure name with a dot. Or if we want to really see the values of the array, of course you can do again a print of team.name. And then you see the 3 names we put in there. Of course, we can also index the arrays of this field. So we can use square brackets directly after the field name. Team, name, and then 1 would give us the name closer. This is rather useful because now we can use the different fields of the structure to do some calculations. And if we use arrays like this, the order will stay the right way, so we can still identify the result with a name. Like, we can calculate how many goals per match each player shot by typing team.goals divided by team.match. But we have to be careful here because both are integer, so we have to typecast them to double before that. And then you see, oh, we have a typo here. It should of course be matches. And then you see it's a double type with a length of 3. And if we want to print that out, we just say print around it. And you see Thomas Müller shot the most goals per match played. Another way of defining structures is to only give the field names without initializing them. For that, we have to use the @ symbol. So we could define the structure WC equals @ and then struct type, and then in parentheses as strings the field names, for example country, wins, and goals, and then close the parentheses, semicolon. Actually, we can even use an array of strings, so we could also have set the same command but with square brackets around the strings to make them an array. And that also works. And if we print WC, you see the fields are all there and they are initialized with the value null. For example, you can use this to create a structure with the same fields as another structure, but without copying the values of the other structure. To get all the fields of the already existing structure, we can use a function. So let's save them in the variable sFields equals get underscore struct underscore field underscore names, and then the structure we want to get the fields from, in this case team. And when we print sFields, you see it's a string array with all the field names in there. So we can define the new structure, let's call it lions equals @ and then struct type, and then in parentheses our array of strings we just got. And then you see if you print lions, it has exactly the same fields but with null as initialized value. I guess you probably think that doesn't seem very useful right now. But we will see in a later tutorial that this is actually pretty nice and can be very helpful. One last thing about structures and arrays, you can also have arrays of structures. So we can combine all our structures we have into one array. So let's say SR equals, and then square brackets for an array. Let's use the structure team, the structure WC and the structure Lions, and then close the array. And you see this is now a struct type of the length of 3. So we now have an array of 3 structures, and those structures don't even have to have the same fields. I think at this point it might be a good idea to talk a little about variable names. There are a few rules you have to follow when naming variables. First of all, variable names cannot contain any special symbols like hash or dollar or %. So if I would say y and equals 8, I get an error. So only letters and numbers are allowed. But you cannot start a variable name with a number, like 5x equals 8 gives us a syntax error. Of course, x5 equals 8 works. And most importantly, ISIS is case sensitive. So the variable lowercase a equals 5 is something else than the variable capital A equals 8. If you look at A, it's still 5, capital A is still 8. So they are completely independent. And then there are words that define a function or are otherwise occupied, and if that is the case, you cannot use them as a variable name. So, for example, the function time, which just prints out the current time on the screen, you cannot use as a variable. So time equals 5 will not work because time is already defined. But here again, structures are very useful because you can still use these words as field names in a structure. So we could say x equals struct of time equals and then an integer array, and let's say this structure has only this one field, and this works fine, and we can address this field by saying x time without problems. So that's maybe another reason why you want to use structures sometimes. Well, I guess that's about all for this tutorial. We learned how to define lists with curly brackets and structures with struct curly brackets, and I gave a very short overview of possible variable names. Thanks for listening.